Okay, this is the bulk of today's lesson. Pay very, very close attention. It's kind of tricky initially. Pay very close attention. It says estimating the area under the curve. Now, remember, the key word is estimate. So assume for a second I have a curve like this, f of x. We're doing A, we're doing B. Okay, we're estimating the area of the curve. Now I'm going to describe to you the challenge. In case you say, Sarama, what's the big deal? I don't get it. Does everybody understand this is not, repeat, this is not a nice geometric figure? And you see, it isn't semicircle, it isn't a rectangle, square, triangle. Okay, next. Here's the second challenge. Does everybody understand? I did not give you what f of x is. Let me say it again. I'm not giving you the function. Now, does everybody understand the challenge?
Yes.
Repeat. I do not give you the actual function, and it's not a nice curve. So hence the word estimating the area of the curve. Now, let me show you how you used to do this in middle school or elementary school. And you guys will laugh and say, oh, yeah, that comes back. Look at the board. Did you divide the figure? Do not write. Feel free to write if you want to, but just have a look at the board. Did you divide that figure into squares?
Yeah.
From elementary school, and just count the number of squares. How many of you remember that?
I remember that.
Yeah, I remember.
And then for those of you who remember, look at the board. If you have half a square, that's half, and you count another half and you make it one square.
One.
If you see a quarter square, you count 4 quarters and make it one. How many of you remember that? It's kind of cute though.
Yeah.
It's
I
exactly.
You
remember.
remember that? So we estimate areas using squares. But does everybody understand that's extremely inefficient?
Yes.
Okay, so here's what we will do. We will use rectangles. Rectangles are more efficient than squares. So I want to show you how we'll do this. I will divide the figure into rectangles or trapezoids. You may say, Rama, isn't a better method even trapezoids? Yeah, we'll divide it into rectangles or trapezoids. Okay, so we will divide, write this down. We will divide so the area into rectangles. So first you just draw parallel lines. Again, just make a note to yourself. Just draw parallel lines. First. Does everybody also understand the more rectangles you draw, the more precise your area will be? Look at the board. These are the rectangles I do. But if I switch to red and draw even more rectangles, look at the board. I draw even more rectangles. You don't need to sketch. Look at the board. Like that. Will the estimate even be more precise?
Yes.
Yes.
Will there be even less leftovers? So it'll be really, really precise. If I had infinite number of rectangles, will that be pretty much the exact area then?
Yes.
Yes.
Is that common sense? If I have infinite rectangles, will that be exactly the area under the curve?
Yes.
Okay, now let me show you the different ways I can draw rectangles. Okay, so we're calling it the concept is called Riemann sum. Okay, so write that down, please. We're on page 13 now. Repeat, we're on page 13. Write down Riemann sums. I'm going to show you how we can draw different kinds of rectangles. Okay, the first concept is a left Riemann sum. Here's how we sketch a left Riemann sum. Okay, assume for a second you have a figure like this. Okay, I'm just going to draw 2 parallel lines for the ease. I can draw 5, I can draw 100. It doesn't matter. I'm just drawing 2. Now pay very, very close attention to how I draw rectangles. Now I need everybody to look at the board. You see these parallel lines and the curve? I go to the top left corner and go rightward. There's your first rectangle. I do the same thing for others. Go to the top left corner and go right. And so we have 2 rectangles. Isn't the area of a rectangle nothing but base times height?
Yes.
And I can add up those 2 areas. Oh, by the way, just by looking at the board, will our estimate, pay close attention to my question, will our estimate, which is just this guy, be an underestimate or an overestimate of the actual area?
Under.
Under.
Because am I having these left over? Can you see that? We're below that. So this is an example of an underestimate. A left Riemann for that kind of figure will give you an underestimate. Is that obvious?
Yes.
Yes.
Okay. Let's draw another example of what is called a right Riemann sum. By the way, this is abbreviated as LRS. This is abbreviated as RRS.
LRS.
Okay. Again, draw a figure like that. Okay, just draw two parallel lines. Okay, I'm accepting a guess. This time, how do I draw the rectangles? For that guy, I went to the left corner and went rightward. For this guy, how do you think we should go?
The right corner going
The right
Okay,
corner
so she's smart. She says go to the right corner and go leftward.
over
Go to the
estimate.
right corner and go leftward.
Okay,
Oh, this time is it an This time is it an underestimate or overestimate?
and
Is my area bigger than the actual area?
Oh, so
Yeah.
there's a track. Wait.
Have a look. The actual area of the rectangles is bigger than the actual area under the curve. Can you see that?
Yes.
So it's an overestimate. Sometimes it's not very obvious, and that's okay. Okay, next week I'll show you what is called the trapezoidal Riemann sum.
Wow. Make this game funny.
It's abbreviated as TRS. Okay. Now you may say, Rama, why does the curve have to go like that? Why not falling? Okay, fine. How about this guy? It's a falling graph. Now let me show you how the trapezoidal Riemann sum looks like. We will do this today. Okay. To draw parallel lines as always. But this time, instead of left or right, I'll just draw a trapezoid. Look at the board. Is that a trapezoid? Let me exaggerate it. Like that. Is that a trapezoid?
Mm-hmm.
Okay, look carefully. Look carefully. Will a trapezoid be an underestimate or overestimate?
Overestimate.
overestimate.
Can you see the actual trapezoid is slightly above the graph? So that's an overestimate. Okay. Finally, let me show you what is called a midpoint Riemann sum. There are four of them we'll learn. Okay, this time let us draw a weirder graph. How about like that? Okay, first step, draw parallel lines. That's always the first step. Draw parallel lines. Now pay very, very close attention to what's going to happen next. I go to the middle of every rectangle. Oops. I go to the middle of every rectangle and identify it on the curve like that. Is everybody following what's going on? I go to the middle. And then I draw the height of the rectangle like that. Convince yourself that it's very hard to say if it's underestimate or overestimate. Do you observe it's a close call?
Close call.
Okay. By the way, it's abbreviated as MRS or MPRS, either way. Some books say MRS, some books say MPRS. So I just showed you different ways we can draw rectangles and trapezoids. Okay. Before I leave, scroll up, please. So let's have a look. For left Riemann sum, pay attention to the rule. We go to the top left and go rightward. Is that clear? For right Riemann sum, we go to the top right and go leftward. Trapezoid is the easy one. Just draw a trapezoid. Just join the corners. And then midpoint is tricky. We go to the middle of every rectangle and then draw the height. Okay. Now let's actually do some problems.
I have a question before you start.
Guys, go to page. What page is this?
15.
Okay, page 15, please. Everybody write on page 15. Yes, Mr. Gurbani.
So for the LRS, can we make the like the rectangles like so much smaller to get like the estimation so much closer to the answer?
Yeah, but they will give you, Gurbani, they will just give you the figure. Don't worry about it. Okay, everybody, there's a thing missing. Write down integral, estimate, right Riemann sum, 0 to 10, f of x dx. Okay, that's the question we're doing. You don't need to sketch the table. Okay. Okay, everybody, I have 15 minutes to do this. Pay very, very close attention. It's tricky. Okay, be with me. Do not fall behind. Okay, what was not given to us in this question?
A graph.
A graph. So for the first and last time, pay close attention. For the first and last time I will sketch a graph, I will never graph it again. I will only use the table. Okay, I'm just showing you. So I'm just going to roughly make a graph. Okay, this is just rough. This is just rough. Pay attention. So at 0, I'm at 2. Hey, guys, this is rough. Okay, this is 2. At 2, I'm at 5. That height is 5. At 6, at 4, I'm at 6. Is everybody okay there? At 7, I'm at 10. And then finally, at 10, I'm at 12. So I'm going to make a rough sketch. It doesn't have to be like this, but I'm just making a rough sketch. Okay, we're starting with right Riemann sum. That's odd. We should have started left Riemann sum. It's not a big deal. We'll start with right Riemann sum. I'm going to show you how this is going. Is that a typo? Okay, fine. Everybody, look at the board. So for a right Riemann sum, here's what we'll do. We'll go to the right. Okay, these are parallel lines. We'll go leftward. Is everybody okay there? Is everybody comfortable with what I did? Let me know if you're confused. This is the time you speak and say, Rama, I don't know what you're doing. I go to the top right corner and go leftward. Okay, now, finally, so write this down. Integral from 0 to 10, f of x dx. Pay close attention, is approximately, everybody, Ms. Chawla, make sure you draw the squiggle. Okay, what's the area of a rectangle?
Base times height.
Okay, I'm going to go to every rectangle, just do base times height, add them up. Is that clear? What's the first base? Everybody look at the board. What's that first base?
2,
2. What's the height of the first rectangle?
5.
5.
Okay,
Oh,
isn't that height 5 here?
Mm-hmm.
Yeah. What's the base of the second rectangle?
2,
2 plus 2 times.
6.
What's the height of the second rectangle?
6,
6.
6. Is everybody comfortable with what's going on? What's the base of the third rectangle? Observe how I'm getting the base.
3.
3,
3. Just 7 minus 4. 3. What's the height of the third rectangle?
10,
10.
And finally, what's the base of the last rectangle?
3,
3.
What's the height of the last rectangle?
12.
Was that stupidly simple?
Yes.
Okay, now I'm going to blow your mind. We will do this without looking at the graph. We'll only look at the table. Everybody, now you need to look at the board. You cannot look down. If you look down in the next 30 seconds, you've lost it. Let me show you how to get this information from the table. Is that first base 0 to 2? And that's over here.
Yeah.
Is your second base also 2 to 4, which is 2? And that's over here.
Yeah.
Is your third base from 4 to 7? And that's 3 here. And your last base 7 to 10, and that's 3 here. Did everybody understand how to get the bases?
Yes.
Okay, now let's observe how we get the heights. Now remember, this is the first rectangle. Let me switch to blue so you can see the board. Now remember, this is the first rectangle. Now okay, sorry. This is your first rectangle. That's your second rectangle. That's your third rectangle. That's your fourth rectangle. So have a look at how we get that 5. Isn't that for the first rectangle, we go to the right guy, 5, and that's that guy. Second rectangle, right guy is 6, and we go here.
Mm-hmm.
Third rectangle is here. Next to 7 is 10, and there's that guy. And last rectangle is 12, height. Yeah.
Basically, it's a pattern.
Did everybody observe the pattern?
Yes.
Yes.
How we can get the thing from the table directly. Okay?
Mr. Ramaswamy.
Now you got the hang of it. Go to page 16, please. Go to page 16. Now we'll do a left Riemann sum. We're still doing integral from 0 to 10 f of x dx with n equals 4. That's telling you 4 rectangles. Okay. So I'm sketching it for you, so you get a feel for this. You don't need to, just watch. Okay, we will do this without drawing a graph. I want to see if learning happened. So integral from 0 to 10 f of x dx. What should I not forget to write? Hint, we're estimating.
Approximate.
Quickly.
Approximately.
Squigglies.
Okay, everybody look at the board. For base, it's the x values. For the heights, is the y values. Actually, take 30 seconds, sketch that table, please. Everybody, sketch that table. I'm giving you time to copy that table. Again, guys, if you do not understand what's going on, Ms. Flores, Mr. Saldana, Mr. Patel, Mr. V, Ms. Juarez, the homework will be gobbledygook. Like, Rama, I don't understand any of this. Flores, are you observing the pattern?
Yeah.
Okay, let's do left Riemann sum. Okay, as before, what's the first base?
2. 0.
2.
No, base is 2, not 0. Okay, for the first rectangle, now I need the left height. Smart kids who got the hang of the pattern. What's the
2.
left height?
2.
2.
Two.
Very good. It's this guy.
Yes.
Okay, for the second rectangle, observe what I'm highlighting. For the second rectangle, what's the second base?
2.
2.
2. Thank you. 2 to 4 is 2. What's the second height?
5.
5. Very good. You got the hang of this. What's the third base?
3.
3. What's the third height?
6.
6. Very good. What's the last base?
3.
3. What's the last height?
10.
10. That wasn't bad at all, right?
It's very simple.
And we can multiply and add. And that will give you a very good estimate, a rough estimate of the area. Okay, this is the time you ask me, unmute yourself and ask me, Rama, I did not understand the pattern. Because I'm going to move on.
64.
Guys, good news. On your homework, I do not want you to simplify. I'm interested in this expression. Is that clear?
Okay.
On the test, you will simplify, but for your homework, 90% of the time, you'll just leave this expression alone. Because I'm hoping at this stage of your lives, you can multiply and add yourselves.
Is there a difference between LRS and RRS in this situation?
Yes, have a look. Look. The heights were different. For RRS, we were looking at heights. For the first guy, the height, and let me switch to red. You say, oh, I see what was happening. He says, I don't see a difference at all. For a right Riemann sum, we were doing first base was 2, and the height was 5. Correct?
Oh, okay, yeah, never mind then.
You're looking at the right heights. Can you see that?
So we could say that there's at least one value that's not going to be included.
Yes. For left Riemann sum, the rightmost guy will not be included. For right Riemann sum, the leftmost guy will not be included for the first guy. Okay. Okay. Now we're doing trapezoidal Riemann sum. So I want you to roughly sketch this figure. This trapezoid is a little weird. As before, 0 is say 2. At 2, I'm at 5. At 4, I'm at 6. This here. It's not drawn to scale. I'm just drawing roughly. Then I exaggerate it. At 7, I'm at 10. And finally, at 10, I'm at 12. Say that's your figure. Now, guys, I have a blue pen, so I can make it easy. You can see, oh, I see what the trapezoid is. Isn't that the first trapezoid? That's your second trapezoid. That's your third trapezoid. That's your fourth trapezoid. Is everybody okay there? That's what the 4 trapezoids are. So let's set it up. So 0 to 10 f of x dx is approximately, good habits. Okay, for those of you who remember, what is the formula for area of a trapezoid?
Average of parallel sides.
Is it the average of the heights, average of the parallel sides, plus, times distance between the parallel sides?
Yes.
Okay, if you have your table, make a note. Oops, oh my God. Half. Okay, write this down, please. This is very, very important. So remember, the parallel sides are the heights. The weakest kids never understand that. The parallel sides are the heights, which are basically the y values.
2 plus.
Whereas the x values are basically the distance between the parallel sides.
Interesting.
Oh, so it's like the.
So,
Hmm.
no, nothing has changed. So the bases are actually the distance between the parallel sides.
Yes.
Everybody look at the table, look at the figure and say, oh, I can see the connection. Okay, let's do this together. Relax, it's very, very easy. So I'll do the first guy. Look at the board and say, oh yeah, I get it. So average of the first parallel sides. Will that give you 2 plus the 5 divided by 2 times what's the distance between the first 2 parallel sides?
2.
2. Observe, I'm sketching for you. Yeah, this guy. Let's do the same thing for the second guy.
Plus
What's the average of the next parallel sides?
11 over 2 times 2.
Good morning. Do what I'm doing. Kids are going to say, where is he getting 11 over 2 from? 5 plus 6 over 2. Kids are saying, where is 11 coming from? Times what's the distance of the next parallel sides?
2.
2 again. Okay, smart kids, now stop. Stop. Can we get this information from the table? Look at the table. Is
Yes.
that 2 plus 5 over 2 times 2?
Yes.
Everybody, look at the table. Look at the table. Again, average of the parallel sides, 2 plus 5 over 2. Next, do we do 5 plus 6 over 2? You see that? And then times 2. Okay, now look at the table alone. Look at the table alone. Which smart fellow will tell me the next thing?
6 plus
Six.
10 over
Very simple. Smart plus 10 over 2 times. What's the distance between 4 and 7?
3.
And what's the last guy?
10 plus 12 2.
Love you. 10 plus 12 over 2 times 3. That's the pattern for trapezoidal Riemann sum. Okay, did everybody not understand the pattern? Repeat. The parallel sides for the trapezoid are the y values. Keep that in mind. I want you to memorize that. Okay, the last one we'll do is midpoint Riemann sum. Gurvani, I hope you understand why I got angry with you. Other kids are going to say, like, what? I thought we were adding numbers. Where did you get 11 from? You're not wrong, but it's going to confuse students.
Very bad.
Okay, everybody, look at the board. This time, how many rectangles are we using?
2.
Two.
Only 2. Now, let me show you why. Again, sketch the figure. So at 0, I'm at 2. I'm at 2. I'm at 5.
Rama, why is that 13 on the top?
Oh, that's a typo. Sorry. 10. I'm in 10. Sorry. 4. I'm at 6. At 7. Okay, I'm going to exaggerate it. At 7, I'm at 10. And at 10, I'm at 12. Now, I do not want you to write for the next 30 seconds. Okay, I do not want you to write. Now, let me show you how midpoint Riemann sum works. Repeat, do not write what I'm going to do next. Now, if you remember how midpoint works, it says go to the middle, okay, go to the middle, and then draw your rectangle. Yes?
Yes.
Do the same thing for the next side. Do not do it. I'm just showing you. I'll go to the middle, which is here, and then draw your rectangle. Just like that. Go to the middle, and then draw your rectangle. But everybody, do I know these heights? Do I know these exact heights?
No.
Do you understand the challenge? I don't have those exact heights. So I cannot do a midpoint Riemann sum the way it is written. Now I'm going to blow your minds. What's this? What's this? On the other hand, what if I made only 2 rectangles this way? Look at the board. I make rectangle 1 and then rectangle 2. Okay, I'm going to blow your mind. What's the midpoint of 0 and 4?
2.
2. And I go to 5 and draw my rectangle. Do you see it fixes the problem? Let's do the same thing. What's the distance between 4 and 10?
7.
6. And half of 6 is 3. Can you see 7 is exactly midway? Do you now understand why midpoint had half the number of rectangles? If I have the original number, I can never make, I do not have the heights. Okay, let's wrap it up. I'll do the first one. So area, which is integral from 0 to 10, f of x dx is
approximately.
approximately, love you. Now pay close attention. Pay close attention. I only 2 rectangles. If you do, guys, girls, feel free to use a different pen. Now this is your first base. This is your second base. Remember, we only have 2 rectangles. Okay, I'm drawing it for you. So look at the board. I need you to look at the board. So what's your first base?
4.
4. And what's your height?
5.
5. Okay, stop. Let me show you where it is in the figure, in the table. Everybody, stop what you're doing. Look at the table. Is that distance 4?
Yes.
Oh,
Yes.
and where did we get 5 from?
The middle.
The middle. If you got the hang of it, let's do the second guy. What's the distance from 4 to 10?
7.
6.
6. And what's the middle height?
10.
10.
10. And that gives you the midpoint.
Rama, I have a question.
Yes.
What if instead of 7, it gives us 8? I mean, it's
Very smart. Guys, he's asking a smart question. He said, Rama, the answer to your question, he says, everybody, look at the board. He says, I understand, Rama, you gave us 0 to 4 and the midpoint was 2. You gave us 4 to 10, and the middle was exactly 7. Because 3, a distance of 3 is, that whole thing is 6. And Gurbani, that's a very smart question. They will never ask a midpoint Riemann sum for those questions. For midpoint Riemann sum, the numbers will always work themselves out. Is that clear? They will give you a table. So when you do half, you'll exactly be in the middle every single time. Is that clear?
Okay, what if it didn't give us that? Can we?
No, then you cannot do a midpoint Riemann sum problem. You can do the others, but you will not do a midpoint Riemann sum.
Wait, can't we use the equation of the line to find a point then?
No. I don't know what the curve really looks like, man. Remember, we are drawing a rough curve like this. What if the curve goes like that? Can you see that?
Makes sense.
We're just making a rough curve. Okay, now we're ready to do examples. Everybody scroll down. Oh, before we move on, let's do a 30-second review of all Riemann sums. I'm speaking to look at the board. We began live with right Riemann sum. Look at the board. Put your pencils down. So we did right Riemann sum, which is the first base times the first height was the right guy. Is that clear?
Yeah.
Second base, which is the distance between the x values and the right height. Okay, for left Riemann sum, it was exactly the same, but we looked at the left heights. So first base times left height, second base times left height, third base times left height. Is that clear? And then fourth base times left height. And Mr. Bilalmino said, oh, so you're not using 12 really. Yes. For left and right, we are really not using one of them, and that's okay. The third one was trapezoid. Everybody look at the board. It is the average of the parallel sides. I'm jogging your memories. Are the parallel sides the x values or the y values?
Why?
Very
Why?
good. So we found the average of the y values. So we did 2 plus 5 over 2 times distance in the parallel side, which is 2. We did 5 plus 6 over 2 times 2. And then 6 plus 10 over 2 times 3. And then 10 plus 12 over 2 times 3. Finally, we discussed the midpoint Riemann sum, for which you'll have half the number of rectangles. The first base is the whole, guys, 0 to 4, which is 4. The second base is 4 to 10, which is 6. Is that clear? And the middle values are the heights. Okay, if you got the hang of this, now we can do 2 word problems, and then we're done with most of the lesson. Okay. Scroll down to page, this one we'll do if you attend office hours. Scroll down to page 23, please. Stay with me, do not follow me. Repeat, we're doing 23. Now you need to pay very, very close attention for the next 10 minutes.
Sure.
Repeat, we're going to page 23.
Do we sketch the graph? Oh, the table.
Okay. Is everybody with me? Oh, she says, do we have to make the table? No, don't make the table. We don't have time to make the table. Let's continue. Okay, do this with me. It says the velocity of an object is a twice differentiable function measured in meters per second. You can write that down. Okay, it's measured in velocity given, measured in meters per second. Selected values of v of t are given in the table below. And part A says estimate a of 3. Okay, who remembers the relationship between velocity and acceleration?
V dash.
The slope of the
Okay,
No,
is that basically v dash of 3?
Mhm.
So stop. Are we finding integrals or are we finding derivatives?
Derivative.
derivative.
Okay, I'm going to say something. See if this comes out from the first semester. I need the acceleration at 3. And I need the derivative. Can I use msec instead?
Yes.
Okay, see if this comes back. Is that v of 6 minus v of 0 over 6 minus 0? Does it vaguely come back? Correct? If I'm finding derivative from a table. V of 6 is given to be
-3. -3.
minus v of 0 is given to be
-2.
-2.
-2 over 6. Is that -1/6? Okay, let's do a review from first semester. Velocity is measured in meters per second. So what would, it says state units. What would acceleration be measured in?
Meters per second square.
Review, meters per second square. That's it. I made an error. Does it use the word estimate? So should I not use approximately? Correct? For msec.
Yes.
From a table, we use approximately. I hope that comes back to you. Was this a stupid just review?
Yes.
Okay, let's move on. Okay, go to page 24. In your notebook, write on page 24. Okay, in your notebook, write that down so you understand what the question is asking. It says estimate integral 0 to 15 v of t dt. Okay. Is there a mismatch?
Yes.
Yeah. No.
No.
No, there is no mismatch. Are we just finding the area under the curve then?
Yes.
Yes? Oh, isn't that the lesson we just did? Estimating area under the curve. And they're telling you use a left Riemann sum with 3 intervals from 0 to 15. Okay, let's do this together. So 0 to 15, v of t dt is approximately, okay, we're doing a left Riemann sum. Okay, let me do the prompting, answer what I'm asking. Do not do your own thing. What's your first base?
3.
3. What's your first height? Left Riemann sum.
Negative 2.
Negative 2.
Very good. Plus, what's your second base?
3.
3.
3. What's your second height?
5.
5.
5. Finally, what's your third base?
9.
9. What's your third height?
Negative.
Negative 3.
That wasn't bad at all, right?
No.
Yes.
Okay, next.
No.
What else does it say?
Interpret.
Interpret the result.
Okay, stop. For those of you who have good memories, what does that expression remind you of?
Average.
Average.
No. It doesn't have a 1 over.
Net change. Net
Okay.
change.
S of
I don't know.
minus S of 0. Wait.
Okay, he's doing net change, which is s dash of t, which is s of 15 minus s of 0, correct?
For meters. Oh.
Yes.
No, we're not done. No, but I'm kind of disappointed. We discussed this today morning. What is that expression? Original expression remind you of? Integral of v of t.
Position.
Oh,
Okay.
Distance?
I still haven't heard it.
displacement.
Displacement. Look at your notes. The integral of v of t is displacement. Does that make perfect sense? Which is net change in position. Displacement or net change in position. Come on, guys, you should memorize your notes. Net change in position. Now, everybody look here. Is a net change in position. So what would your units be?
Meters.
Meters, thank you. Measure in meters. Over the interval 0 to 15. Is that what? Seconds? Yeah, seconds. Perfect interpretation. But guys, memorize integral of velocities is displacement. You don't have to apply net change. You can apply net change, but memorize the integral of velocities displacement.
Yes.
Okay,
sir.
next. Right on page 25. Repeat. Go to page 25. Now in your notebook, read this sentence. The object's position is initially given as x of 0 equals negative 4. Do not get alarmed. The AP uses the word s and x the same way. So is that a position? Is that basically s of 0?
Yes.
Is everybody okay there? Okay, where's the question gone? Okay, I'm writing the question. Okay, I say estimate. Write this down, please. Estimate the position of the object. I don't know if I have a question like this below. One second. I don't know. 1 second, guys. Okay, I already have it. I have it. Guys, ignore this question. This is like a blank question. This is annoying. Just go to page 26. Go to page 26. Repeat. Just go to page 26. Okay, what does 26 say?
Integral from 0 to 24 after the value.
Not 26. Are you on the right page?
Yes.
Yeah.
No, it says, doesn't 26 say estimate the
Average velocity.
average velocity? What are you doing, Villarmino? You're confusing the class.
Wait, what?
Page 26. What are you doing?
I think your 26 is 27 for us.
Okay. But no, Gurmani, that's because of the stupid Word document, remember?
Oh.
Okay, guys, just look at the board. Just look at the board. It says estimate the average velocity. How do we interpret it literally? Exactly the way it's written.
AV.
AV.
Equals
AV
1
equals
30.
Integral from
30, the integral
From 0 to 30.
30.
V of t dt.
Yes.
yes.
Okay, stop. Is there a mismatch?
No.
No.
So are we just integrate? Are we just finding the area under the curve from 0 to 30 BOT? Yes.
Mhm.
Yes.
Okay. And it says using a
Midpoint.
Midpoint.
midpoint Riemann sum with 3 intervals. Everybody look at the board. Let me draw it for you. Look at the board and say, oh, I see what's going on. In your homework, do draw the table. So is that your first rectangle, second rectangle, and third rectangle? Because that's a midpoint Riemann sum. Okay, I want to see if learning happened. What's your first base going to be?
6.
6, from 0 to 6, Miss Flores. For those of you who get the hang of the pattern, what's the middle height?
5.
5. Okay, what's the base from 6 to 24?
18.
18.
Very good. What's the second height?
2.
Very smart. What's the last base going to be?
6.
6.
6. And what's the middle height?
1.
1.
That wasn't bad at all, right?
No.
Okay, we went over this last week. I want to see if learning happened. It says average velocity. So what would your units just be?
Meters per
Meters.
Average velocity.
Meters per second.
Meters per second.
Meters per second. Remember, the only unit that changes is average rate of change. Does that come back to you?
Yes.
The other two functions, net change and average, have the original functions. So this is average velocity, just meters per second.
Mhm.
Okay, next. Go to page 27, or just look at the board. Just look at the board. Okay, copy down that expression. Stay with me, do not fall behind. Okay, it says 0 to 24, write Riemann sum. In your notebooks, write down. So does that just say find the integral of absolute value of t? Okay, now pay very, very close attention. We kids always get this wrong. It says take the absolute value velocity. Look at the board. Aren't those the velocity functions? If you're taking absolute values, the negative 2 will become,
Positive.
Positive 2.
the negative 3 will become,
positive.
the negative 4 will become,
4.
and negative 6 will become.
Positive.
Did everybody understand what that absolute value of velocity does? All the velocity will turn positive. Okay, let's do this. It says using a right Riemann sum. Okay, let me draw the bases. We're going from 0 to 24 only.
Mhm.
Okay, stay with me. What's your first base?
3.
3.
What's your first height? Oh, by the way, approximately. What's your first height?
Negative
5.
2.
Right Riemann sum.
Oh.
Pay attention. Right Riemann sum.
I'm sorry. I don't know my left and my right.
5.
5. Okay, 1 second. Let me erase this so it's not confusing. Okay. Okay, smart kids, careful. What's your second base going to be?
3.
3.
Careful. What's
Nine.
your right?
3.
3.
Positive 3. Miss Ramirez, positive 3. The velocities are turning positive. What's your third base going to be?
9.
9.
Height.
Times
2.
2.
2.
2.
And finally,
9.
9 times.
4.
4.
Very smart, because all velocities are turning positive. Careful. This is tricky. This is tricky. Oh, it says, it says interpret your result. We discussed this earlier, 20 minutes ago. Who remembers what that expression reminds you of?
Displacement.
Distance.
Or distance, yeah.
Distance. Thank you. Write this down. You have to memorize your notes. Distance traveled by the object over.
0.
Oh, by the way, what would distance be measured in? Common sense. Meters per second, meters per second square. Distance.
Meters.
Meters.
Meters over the interval 0 to 24. Is that seconds? Again,
Yes.
you need to memorize your formulas. The integral of velocity is displacement, but the integral of absolute value velocity is distance. Memorize your notes. Okay, we are on page 28. Okay, this is stupid. Guys, this is 1 second. This is actually 6 to 30. Write this down. Okay, stay with me, do not fall behind. Okay, let's interpret the question the way it's written. What's the definition of displacement again?
Change in position.
Or kids with slightly stronger skills, what can we directly write?
Integral
Integral from
6 to 30.
okay. Think before you answer. Is it V of t or absolute value of t? This is displacement.
BFT.
Just V of t. You could do change in position. Don't get me wrong. You could do net change in position, the net change. Okay. It says midpoint Riemann sum from 6 to 30. Let me sketch it for you so you can see what's going on. Okay, do this yourselves. Approximately.
According to Merriam-Webster.
Okay, do that yourselves. Do that yourselves. Go on. Those of you got the hang of it, tell me what you're writing.
18.
18 times
2.
midpoint. 2, very smart. Plus.
6 times 1.
1.
Okay, this is just displacement. So what would your units be?
Meters.
Meters. This is a change in position. This meters. I have most of you have got the hang of it. Is there anybody confused? I will not scold you. I will not shame you. Mr. Alnabalsi, Ms. Andelkovic, Mr. No, Mr. Manasra, Ms. Juarez, Mr. V, Ms. Flores, Ms. Madero, Mr. Gonzalez. How are you chaps doing?
Okay.
Okay. Everybody, stay with me. Do not fall behind. Look at the board, please. It just says estimate the value of x of 27. Remember I said x is nothing but
S.
s. They want s of 27. And smart kids, if you remember, didn't they give us s of 0 was -4?
Yes.
Okay. So be alive. We need s of 27 and we know s of 0. And we know the derivative.
Corollary.
Net
Are we
change
using the net change
corollary.
corollary?
Yes.
Okay, tell me what to write.
S of
S of
0.
S of
0.
0 plus integral from 0 to 27 S dash.
S dash of dt.
Ooh, and what's s dash after all?
BFT.
V of t dt. Okay, let's substitute. What's s of 0 given to be?
-4.
4.
Plus. Is that just area under the curve for the velocity function? And we have the velocity function, correct?
Yes.
And we want a
Right, Reimann.
right Riemann sum. Okay, from 0 to 27. Okay, for practice, I just want you to write the first two and the last one. Repeat, only the first two and the last one. Okay, what's the first?
3.
Time
Times
5.
5.
5, right Riemann sum. Very good. Second one,
3
Three.
times -3.
negative 3.
S of
And
3.
then the dot dot dot, last one.
3
Nine.
times -6. -6.
We're stopping at 27.
3 times
Oh.
1.
Right, we're
One.
stopping at 27. Is that one?
Yes.
Okay, the question Ms. Ramirez just said S of 27. Is this fairly straightforward? You see how I'm combining net change corollary with Riemann sums? I'm kind of tying up concepts.
Mm-hmm.
Okay, next. Next page, please. Okay, copy down this.
What page is it? Oh,
This is page 30. Repeat, page 30. Okay, do we have a mismatch?
Yeah.
yes.
So I can cross out A of t and write
V dash of
V
t.
dash of t.
very smart. So net change kicks in. What am I writing?
V of 30 minus V of
Yeah,
6.
30 minus V is 6.
Is everybody okay there?
Mm-hmm.
Yeah.
What's V of 30 given to be?
Negative
Negative
6.
36.
What's V of 6 given to be?
Negative 3.
Final answer?
Negative
Negative 3.
Stop.
Meter-
It
oh,
says interpret your result. Everybody look at the board. You're learning something brand new. Everybody look at the board. Again, stop what you're doing. Look at the board. The answer can be no. Is there any interpretation we know of this directly? Look at the board. Look at what I'm circling. Do we know the integral of A of t? Is there anything we have memorized for the integral of A of t? No.
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 Have we memorized anything for the integral of A of t? No. Yes or no?
No.
No. So pay attention. Pay attention, please. If we do not know the interpretation of something they give us, we use net change. Oh, do we know the interpretation of that guy?
Yes.
Yes.
It reminds you of
Net change.
Net
net
change.
change. Love you, Ramirez. Is the net change in
Velocity.
Velocity.
velocity? Pay attention, Bellarmino. That's the velocity. Net change in velocity of the object. Two, net change in velocity. So what would their units be?
Meters per second.
Meters per second.
Don't overthink it. The only thing that is weird is the average rate of change, guy. Is that clear? Over the interval 6 to 30. Now, once again, let me just repeat. That's in seconds. If you cannot interpret the question, rewrite it and interpret the rewritten question. Let me say that again. If you cannot interpret the expression they gave you in terms of net change, average rate of change, or average, rewrite it and the interpretation should show up. Okay. We're on page 31. Okay. Let me write this on the board, which is your 31, 29, 30, 31. Okay, guys, it says total distance from 3 to 24. That's really the question. Using a trapezoidal Riemann sum. Write that down in a notebook. Trapezoidal Riemann sum. Okay, this is a very important problem. It is on your test. Feel free to draw a skull. I'm letting you know this question on your test. I'm informing you. Okay, who remembers from the first 20 minutes of class what the definition of distance is?
Absolute value of velocity.
Value of
Or rather, the integral. Correct?
Yeah.
Actually, write down distance first. Distance equals integral 3 to 24 absolute value velocity dt. Okay, I want to see if learning happened. If it says absolute value v of t, all the velocities should turn
Positive.
positive. So I make it easy for you to watch. Look at the board. Is everybody okay with what I'm doing?
Yes.
And I want 3 to 24 only. Okay, 3 to 24. And we're doing a trapezoidal Riemann sum. This is the weird guy. So I'm going to go over this again. I'll do the first one. You guys do the other one. Remember, the trapezoid is average of the parallel sides. Are the parallel sides x values or y values?
Y value.
Y value.
You write something on the board. Look at the board and say, I get it. 5 plus 3 over 2 times. What's the distance between the parallel sides?
3.
3.
3. Okay, do the others yourselves. Plus
3.
3 plus 2
Plus
over
2 over
2
2.
Over 2
times
9 plus last one.
4. 2 plus 4
Plus 4 over 2
4
divided by
over
2
2.
times 9.
9. That wasn't too bad, was it?
No.
Okay, but that's kind of tricky. What? All the velocities will turn positive and it will trapezoidal Riemann sum. Guys, this was distance. So what would your units be?
Meter.
meters.
It's not difficult. Okay, almost done. Almost done. We're on page 32, please. It says find the average rate of change. Oh, sorry, estimate the average rate of change of the object's position 0 to 24. Interpret it literally. Do not speak. Interpret it literally. Average rate of change of position.
Times of S of 24
24 minus S of 0 over 20.
Thank you.
24.
Position, average rate of change. S of 24 minus S of 0 all over 24.
24.
Is there a mismatch?
Yes.
Yes.
Yeah.
So what should I pull out?
1 over
1 over
24.
24.
1 over 24. Very good. Brackets. Can we use net change for that guy? Integral of.
0 to 24.
24.
S dash
S
B.
B.
Ooh, and what's the dash after all?
B of
B of T.
And now, is that just the area under the curve for the velocity? We know velocity, correct? And they say using a midpoint Riemann sum 0 to 24. Okay, do this yourselves. Do this yourselves. Midpoint Riemann sum 0 to 24. I sketched it for you to make it easy. Okay, go.
6
times
6
5.
times
5.
5 plus
18.
18
18
times
times 2.
That's how easy that was. Okay, guys, this is the tricky one. It says average rate of change of position. So what would your units be?
Meters per second.
meters per second squared.
Love you. Isn't the average rate of change of position basically velocity or rather 1 up? And we write the units of that guy. So meters per second.
Yes.
Mhm.
It's the slope of position, which is velocity, and we write its units. That's the weird one. Okay, we're almost done.
Almost.
Next guy, right on page 33 on my document, page 33.
That looks like an average.
Okay, this is a left Riemann sum 3 to 27. Okay, you guys do this yourselves. Only just do the first one and the last one. Repeat. Do the first one and the last one only. Oh, approximately. Don't forget approximately. Oh, by the way, there's no mismatch, correct? We're good to go. Okay, what's the first one? Hint, left Riemann sum.
3 times -2.
Silly boy, 3 to 27. Pay attention.
5.
5.
Again, everybody, you need to look at the interval they give us.
Oh,
So
3
3
times 5.
times 5 plus dot, 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 just do the last one.
3 times -4.
Up to 3 times -4. Okay. By the way, let's interpret this. Look at that expression. Does that remind you of one of those three?
Average.
Average.
Average of.
Velocity.
Velocity.
Don't overthink it. It's this guy. Average of
Velocity.
velocity. Guys, it's average. Therefore, the units don't change. So, what is the unit for velocity?
Meters per second.
Okay.
Average of velocity of the object. Sorry, I should have done of the object. Over the interval,
3 to 27.
and that's in seconds.
Ram, I have a question.
Yeah, go on.
And can we write the average rate of change of the position?
Position, absolutely. Yes.
Okay.
Okay, last question of the day. Everybody, last question of the day. Okay, you don't need to copy anything down. Okay, just read it with me. Just read it with me. The volume of water in a tank is changing at a
Rate.
rate. So smart kids, what do we always do for rate problems immediately?
A of t.
A of, love you. He got the hang of it. A of t be the
Volume.
amount. Very good.
Water.
Water.
At time t.
At time t.
Gallons.
Okay, this is the last problem of the day. In gallons. And then A dash of t is,
RT.
R.
which is W of t, right?
WT.
Give us WT.
Which is
That's the
rate
rate.
of change
Rate of change.
This is the
of
rate of
amount of
change.
water
in the tank. At time t.
gallons per minute.
Per minute.
Amount of water. This is the last question of the day. Of the amount of water in the tank. The time t measured in gallons per hour.
Minute. Per minute.
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 Yes.
Did they give us? Oh, yeah. Thank you. Gallons per minute. Okay, we have time to do only this problem. We're done for the day. Okay, it says use a trapezoidal Riemann sum with 3 intervals to estimate the amount of water in the tank at t equal to 10. Oh, well, sorry. It says initially there are 20 gallons of water in the tank. So what are they giving us?
A of
0, which is
Are we
20.
using the hang of it? A of 0 is 20 gallons.
Mhm.
And the question says estimate the amount of water at t equal to 10. So what are they asking for?
A of 10.
A of 10? Oh, we know A of 0.
Net change corollary.
or Lara.
Tell me what to write.
A of 0.
A of 0 plus
Integral
From 0 to
0
10.
to
0
10.
to 10.
A dash of
A dash of t.
Actually,
t.
And isn't A dash of t nothing but W of t?
Yes.
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 Correct? So, guys, I'm going to say something profound. Think about it and say, oh, I get it. Okay. At this stage, I'm going to use the Riemann sum. It says using a trapezoidal Riemann sum. Because I'm using a Riemann sum, should I write approximately?
Yes.
Because I'm getting ready to use a Riemann sum. A of 0 is given to be
20.
20.
plus. Okay. We're going only from 0 to 10, guys. Everybody look at the board. I'm drawing it for you. We're only going from 0 to 10. So we're doing trapezoidal Riemann sum. Okay. Who's got the hang of it?
It's
2
2 minus
minus 1 over 2
Times 1 or 2 plus -1 over 2 times
times 3.
times 3.
3. Very good. What's the second trapezoid?
-1.
-1 plus 5.
-1 plus 5 over 2 times
Every 2 times 3.
3.
and distance between the parallel sides plus last heights
5 minus 3 over 2.
Over 2.
5 minus 3 over 2 times what's the
Three.
distance between them?
4.
4.
4.
Whew. So we tied up a word problem with net change corollary, and Riemann sums. Okay, like 3 concepts together. Okay, so
Rama.
that was the real big lecture. So I'm taking 30 seconds. So look at the board, please. We began live. My stupid mouse is not working. Otherwise, I'd be faster. Half the time I take up like scrolling up and down and trying to figure out. So let me scroll back so you can see what happened. So this problem, we did a whole bunch of Riemann sum problems. All right, word problems. If you attend office hours, I'll do more examples. Okay, there are examples I did not get to do. but I strongly recommend you do office hours. At the very least, if you can't stay the whole time, at least half an hour. Half an hour is better than 0 minutes. Okay. So we did Riemann, sorry, we did net change corollary with Riemann sums. And then we had Riemann sums with distance, displacement, average position, blah, blah, blah. Whole bunch of variation of problems. We did interpretations. The only units that are weird are average rate of change. Is that clear? Then we did just simple Riemann sums. We discovered shortcuts. And then we went over how to draw Riemann sums. So look at the board, please. Everybody, look at the board. So I showed you how to draw a Riemann sum. We go to the top left corner, go rightwards. Right Riemann sum, right corner, go leftwards. Trapezoid Riemann sum, just draw trapezoid. Between a Riemann sum, go to the middle, and then draw your rectangle. Is that clear?
Mhm.
We also talked about whether it's underestimate, overestimate. It's kind of obvious, okay? But we went over that. And then we discussed, the last concept we discussed was distance versus displacement. Distance is the absolute value velocity. Is that clear? Whereas displacement is just the integral of velocity. All right. And then finally, we did absolute value integrals. You break it up at the, what do we find first?
The x values.
X-intercepts.
The first one for the breakpoint. We split up the integral. Make sure you find the absolute value of each of those integrals, because I don't know if it's positive or negative. Add them up, and that's your result. Okay. I think we're good to go. Okay. Thank you so much. I hope to see you.
Bye.
Thank
Thank you. Have a nice
You have a nice day.
Thank you. Thank you.
Rama, before we go, can we go